Hey guys, here I'm going to go over how we can graph some exponential functions. Now, it's really not necessary to ever use a table of values when graphing an exponential function. I included them just so you would have the option. I'm going to go over both ways and then I'm going to default to the way I find easier. First thing that I'm doing is I'm drawing two dashed lines. The purple dashed line will represent my horizontal asymptote down at -7, and the vertical orange dashed line just represents where my y-axis moved. My y-axis had to shift 4 units to the left. These two dashed lines help me recalibrate my center of my exponential function. Not that there's really a center, but it kind of gives me somewhere to call home. Home will be -4, -7. All we have left to use are the 2 and the 3. The 2 out front is my vertical stretch, or my initial value. However, my whole graph has moved left 4 and down 7. That doesn't change the fact that your initial value of 2 is still 2 units away from where your two dashed lines crisscross. The 3 is the base in the problem, which is still telling me I multiply by 3 every step of the way. So, since the first point was 2 units above my horizontal asymptote, the point to the right of it, 1 unit, will be 3 times as many points above my horizontal asymptote. That means I need to move 6 units above the horizontal asymptote. Every time I move over 1 more point, I'll triple how high up I am. So 2 units away from the crisscross, I'll have to move up 6 times 3, 18 points. Our transformations, we could really just write down that our base is 3. We have a vertical stretch of 2. We went left 4 and down 7. The domain for this first example is -infinity to infinity. The range, which goes from the bottom to the top, is from -7 with a parenthesis, since we never actually touch the y value of -7, until infinity. If you want to use a table of values, you probably learned pretty quickly that if you fill in -2, -1, 0, 1, 2, it's not always going to be very helpful. You're probably getting really huge numbers and finding yourself pretty disappointed. This is one of the many reasons why using a table of values is completely ridiculous. However, if you're dead set on using a table of values, just make sure you make the middle number in the table of values the middle of your graph. I know that our graph really doesn't have a middle since it goes on infinitely in both directions. If I move to the right, I'll have -3 and -2. So if I move to the left, I'll have -5 and -6. If I fill each of these numbers in, I'll get the following numbers. -4, -5, which totally checks out with my graph. -3, -1, which also checks out with my graph. -2, 11, third point that definitely lines up to the points I got without any algebra at all. And then a fourth point, -5, if you fill in -5, -5 plus 4 is -1, 3 to the -1 is 1 over 3 to the first, 1 over 3 to the first is 1/3. 2 times 1/3 is really 2/3. 2/3 minus 7, I'm already upset. I don't feel like doing this. I could think of it as -7 plus 2/3. That's helpful for graphing because you could just go down 7 and then up 2/3 and plot your point. However, if we really wanted to get an improper fraction, we'll multiply that 7 on top and bottom by 3. That would give me 2 minus 21 all over 3. 2 take away 21 is -19. -19 thirds goes with -19 thirds is the output value for my input value of 5. Now that you can see that all of that arithmetic and all of that hard work coming the same exact picture I got by just drawing in my two dashed lines, one of which is a horizontal asymptote, and then using my initial value and my base to figure out a handful of other points. This probably shows you how silly it is to use a table of values and how it's really quite the waste of time. Here we have another example. +5 at the end of my equation tells me I'm moving 5 units up. X minus 3 in my exponent tells me I'm moving 3 units to the right. Once I have my two dashed lines, my vertical line and my horizontal asymptote, I'm going to use my initial value first. It's -1. That means from this crisscross, I'm going to move 1 unit downward away from my horizontal asymptote along my vertical line. My base is 2. That tells me as I move to the right, I will double how far away from my horizontal asymptote, I am. If I was down 1 unit before, now I'll be down 2 units. For the next point, since I was down 2 units in the last step, I'll be down 4 units in this step. One more point over, I'll be down double the -4, so I'll be down 8 units. The domain, as it is for all exponential functions, is from -infinity to infinity. The range for this example is from -infinity until 5 with a parenthesis, since I'll never actually reach that value of y equals 5. I can continue with this. I could create my table of values, and as you can see, everything will check out and I'll get the same values that my graph already showed me I had. For this next example, the -8 at the end of the equation tells us we're moving down 8 units. Our exponent of x plus 5 tells us we're moving 5 units to the left. The 1/2 is our initial value. I'm going to move up 0.5 units from my horizontal asymptote along my dashed vertical line. The base, 4, tells me I'm going to quadruple how far I am from the horizontal asymptote every step of the way. If I quadruple 1/2, I get 2. And if I quadruple 2, I get 8. I'm not going to go any further because these numbers are going to be quite large. In my transformation box, I'm just going to write down that I had a base of 4. I have a vertical compression of 1/2, left 5, and down 8. The equation of my asymptote, since it's horizontal, is y equals -8. Domain is always -infinity to infinity for exponentials. And my range is from -8 with a parenthesis until infinity. Feel free to fill out your table of values. Just don't forget that for your table of values, you need to look at your exponent to decide where that middle point of your graph is. X plus 5 tells me the middle of my graph will be indicated. The middle of my graph is at x equals -5. Then I'll choose 2 numbers on either side. I probably won't use the numbers to one side of my middle because I probably don't feel like dealing with fractions. You definitely don't need to, but you could write it down just to get things started. Once you know which numbers you want to use, just stick with them. For the fourth example, we have f of x equals -1/3 times 6 raised to the x minus 6 plus 9. Dashed lines need to go into the picture. My transformations, I could write down b equals 6. There's a vertical reflection, that's what's indicated by the negative in front of the 1/3. A vertical compression of 1/3. Make sure you're not writing down that you have a vertical compression of -1/3. Your stretches and compressions should never indicate the negative. The negative with your a or in your exponent always represent reflections. The -1/3 tells me that from where my 2 dashed lines intersect, I'm going to go downward 1/3 of a unit. As I move to the right, I'm going to multiply that distance by 6 each step of the way. -1/3 times 6 is -2. So 1 unit over, I'll be down 2 units from my horizontal asymptote. Now, -2 times 6 gives me -12. That means 1 more unit over, the distance between my horizontal asymptote and my exponential function will be 12 units in the downward direction. If you fill in your table of values, you'll see that all of these numbers totally check out, and you just get them as ordered pairs instead of thinking of them as movements from the intersection of your 2 dashed lines. Here for number 5, right 2, up 8, I draw in my 2 dashed lines. The -2 tells me I start down my orange dashed line 2 units. 1/2 tells me as I move to the right, my distance will cut in half. 1 unit over, half of -2 is -1, I'm down 1 unit. Half of -1 is -1/2. 1 more unit over, from that horizontal asymptote, I'm down half a unit. Well, this is annoying because I don't want to get smaller numbers. Instead of cutting my distance in half, I'm going to double it. So, 2 units down, doubled, becomes 4 units down. 4 units down, doubled, becomes 8 units down. 8 units down, doubled, becomes 16 units down. Connect all your points, arrows on both ends, and we'll get our continuous exponential function. The domain is again negative infinity to infinity. The range is from negative infinity until 8, where 8 is not included. The horizontal asymptote is at y equals 8. For a table of values, since the exponent is x minus 2, I'm going to make the middle value for x 2. Then I'll choose two numbers on either side of 2. That means my table will include 0, 1, 2, 3, and 4. We evaluate our exponential function at each of these x values. You'll see we get 0, 4, 6, 7, and 7.5. Each of these ordered pairs lines up perfectly with the points I plotted previously. For the last two examples, I'm asking you to come up with the equation from these details. My asymptote's already indicated for y equals 5, so I could draw in a horizontal asymptote at y equals 5. The middle x value in my table is 4. That tells me my vertical line will be at x equals 4. This information tells me that my graph was moved right 4 and up 5. The y value of 4 goes with my x value of 4. If I plot that point, you can see that it's 1 unit down the dashed orange line from my horizontal asymptote. That means my initial value is negative 1. The next point I have indicated by the table is 5, 2. If I plot that point, I'll see that my distance has tripled. Since my distance has tripled, that makes my base 3. If my base is 3, I can write my equation of f of x equals negative 1 times 3 raised to the x minus 4 plus 5. A few other points are indicated by the table. Example 8, I'm going to go about it the same way. Y equals negative 6, I drew in my horizontal asymptote. The middle of my table shows me an x value of negative 2, I drew in my vertical line. When x is negative 2, the y value is positive 2. So if I go to the origin and move left 2 units, up 2 units, I'll land on my vertical orange dashed line. How far is this value from my horizontal asymptote? Since I'm 8 units away, that makes my a, or my initial value, 8. The other ordered pair indicated is negative 1, negative 4. Since this point is only 2 units away, it seems pretty obvious to me that my graph has a base value of 1/4. The a value of 8 tells me my graph has a vertical stretch of 8. My 2 dashed lines tell me that my graph has been translated left 2 units and down 6 units. Make sure you put arrows on each end, as an exponential function continues indefinitely in both directions. The function for this will be f of x equals 8 times 1/4 raised to the x plus 2 minus 6.